Colby, math.com.
We learned about box and whisker plots today and how to calculate the different quartiles and use those to calculate interquartile range, which is a better measurement than range for indicating consistency and predictability of the data. We did a double box and whisker plot in class, I hope, on the notes, but if we didn't, this is another opportunity to do so. I've got bowling scores for Herman and Samantha. If this is another year and I used different students and I didn't reshoot the video, please forgive me. It takes a long time to make these videos, so there's a chance I might be reusing this. In order to create the double box and whisker plot, first I need to order the data from least to greatest, and that takes a bit of time. I look at Herman's scores. The lowest, I don't see any double digit, I see everything triple digit, so I'm pretty sure this 101 is going to be the lowest. And you know what, I think I'm going to do this here because it's going to be a long list. The 101 would be the least. I'm going to put little dots above as I go. Is there anything in the 110s? I see 118. I see 111. I didn't see 10 anything, so 111 followed by 118. And then the 120s, 125, 129, I think that's it. 130s, just 135. I saw some 140s, there's 149, 146, 142, so 142, 146, 149. I see 153 and 156. And there's 162. And then these two really high scores, the 200 and the 273. Now, there's something really important you have to do after you make a list like this, especially a long list like this one. You really want to count your original set of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and compare it to your new list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you don't take the time to do that step, you'll often miss the opportunity to catch an error. It'd be very easy to miss one of these data points as we're doing this. Samantha's list is a bit shorter, so shouldn't take as long. Samantha. The smallest I see is 114. Any 120s, there's a 125. 130s, no, but there's several 140s. 140, 146, 149, 140, 146, 149. No 150s, but there's a 162 and then a 172. And then the two big scores, 200 and 260. 300 is a perfect score. She started with 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, and our new ordered list has 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. The next thing to do is to find the quartiles. Quartile 2 is the median, and we've been finding median for a while, so that isn't any different than finding median for any ordered list like we've been doing. But then quartile 1 and quartile 3, refer back to your notes and the work we did today during the pause and see if you can find quartile 2 and then quartile 1 and 3 for both of these lists of data during the pause, and then come back and see how you did.
Paused.
Herman's data has 14 data points, so there will not be a data point in the middle, but the 7th and 8th pieces of data will determine the median. They happen to be these two, 142 and 146, and so quartile 2, or the median, would be equal to the average of those two. I could take 2 from the 146, give it to the 142, and then they'd both be 144, using that idea of distributing the data evenly to find the mean. We could add them together and get 288 divided by 2 is 144. But in any case, the median is 144 for Herman. The median for Samantha, Q2, will be the middle number. She's got 9 pieces of data, so the 5th one will be the middle number, or the median. So Q2 for Samantha is 149. When you're finding quartile 1 and quartile 3, quartile 1 is the median of the first half of the data. And the first half of the data and the second half of the data never include the median. So if the median is part of the data, you don't include that. But for Herman's list of data, the median is not included in the data. So the first half of the data would include all 7 of these numbers. And similarly, the upper half of Herman's data does not include the median. The 144 is not included. Accidentally triggered some hotkey there that I've never seen before. Hopefully it didn't mess up the video. So Herman's upper half of his data looks like that. And so if there's 7 pieces in the lower half, the 5th one, the 4th one will be the middle. And so this is Q1 for Herman, 125. And the 4th one in this upper half will be Q3. It's 156. Those quartiles split the data into 4, not necessarily completely equal pieces, but close enough for what we're going to do. Samantha's lower half of her data will not include the 149 because the median is not included in these halves by definition. So it'll go from 114 to 146. The upper half will go from 160. Wish I knew what I was doing to cause that. From 162 to 260. And so the median of the lower half will be the average of these two. The sum is 265. 260 halved is 130, and 5 halved is 2.5. So 132.5 will be Q1. 132.5. These two add up to 372. 360 halved is 180, and that extra 12 halved is 6. So Q3 is 180 and 6, so 186. Double checking myself, 360 and 12, 372. Yeah, that looks good. And now that we've got Q1, Q2, and Q3, we can make the box and whisker plot. I've looked at this number line ahead of time, and I know that there are plenty of lines for me to make them each 10, and I won't even necessarily need to start with the first line, which I think is good because we want some room for their names. So I'm just going to start with 100 right about here, and I'm not going to put 110, 120 and crowd all my numbers. I'm just going to count 10, 20, 30, 40. This will be 150. 60, 70, 80, 90. This will be 200. 210, 220, 230, 240, 250. 260, 270, 280, 290. And a perfect score would be 300 right here. And then we've got plenty of room to put Herman's data. I'll probably put it way up here. Double box and whisker plot is going to take some space. And then Samantha down here. Samantha's median, Q2, is 149. So I'm going to draw a vertical line at 149, which I think is right about there. And then the box is made from Q1 to Q3. So the width of that rectangle is your interquartile range, the distance from Q1 to Q3. Q1 is at 132.5, so 110, 120, 130, 132.5 is probably right about here. I don't think I did that very well, but you know, I'm meaning for it to be to the right of the 130, of course. And 186 would be just before just after the midpoint between 180 and 190, so probably right about there. And then I just close in this box. The whiskers will go from the, that is quite annoying. Can I disable? Oh, I can disable it. I should have read that a long time ago. Should be the last time we see that. Where is it? I'll make a sound. I'll turn sticky keys. Turn on sticky keys. I'll probably regret that later, but not as much as I regret the interruptions of this video. So the minimum is 114. It's a little dot here, and you go from that dot to the box. There's a whisker. The other whisker will go from Q3, which is the rightmost edge of that box, to the greatest value, which for Samantha is 260. And there's the box and whisker plot for Samantha's data. Herman's data, the median is 144. So 140 is here, 150 is here, right about halfway. That's my best effort at that. And then the Q1 is 125, so midway between 120 and 130, about there. And Q3 is 156. 150 is there, 160 is there, so 156, I hope, is right about there. Close in the box. The whiskers go from the minimum value, which is 101, just right past 100, to the box, and maximum value 156. No, I'm looking at my original data. I need to look at my ordered list. It goes to 273, 250, 260, 270, maybe right about there. It's so annoying. I don't know what it is. I think something about the writing tablet is triggering something, but in any case, that is the double box and whisker plot. And you can tell a lot about the data by looking at the width of these boxes. The width of the boxes is the interquartile range. You'll need that for some upcoming questions. It's the difference between Q3 and Q1 for each set of data. Will give you the interquartile range, which is different from the range, which would be the difference between the very highest and very lowest values. That only tells you variability, but interquartile range tells you more, and we talked about that in class, so I'll leave that to you to explain. Thank you for watching the video. See you tomorrow.